So I'd like to ask Dr. João César Freitas, who will be the chairman during this morning, and well, the whole day actually.
Muito obrigado, Roberto. Bom dia a todas, senhoras, bom dia, senhores. Antes de iniciar nossos trabalhos, nós gostaríamos de fazer um minuto de silêncio pelas vítimas das enchentes em Santa Catarina. Já são mais de 250 mil desabrigados, mais de 100 mortes, pelas vítimas dos atentados terroristas em Mumbai, na Índia. Muito obrigado. Temos um dia cheio de palestras. Nós vamos começar pelo Dr. Richard, da IOM. Dr. Richard, por favor, à mesa. Também a sua palestra. Fique à vontade. Vamos começar.
Mr. Chairman, distinguished participants, it's my great pleasure to meet you. I would like to present formation of mineral resources in the South and Equatorial Atlantic Ocean. Please. As you know, in the 21st century, the global society faces a potential threat to sustainability of the natural environment and to quality of life on the earth. Therefore, rational activities of the humankind should be directed and ensuring civilization development aided by use of natural resources, but with a complete understanding of their limited and finite nature. As you know, International Geological Society and UNESCO proclaimed years period 2007-2009 year of the planet Earth. The initiative of Ministry of Mines and Energy, Geological Survey of Brazil, and the International Seabed Authority to convene this seminar is extremely timely and important. It's impossible, I hope you agree with me, it's impossible to discuss oceanic metallic deposits formation without considering first evolution of the Earth's ecosystem and oceans and elucidated by global plate tectonic. The analysis showed that the differences between the Earth's ocean are a direct reflection of their stage-wise development. The differences in the structure and tectonic of the oceans are a result of differences in geodynamic processes taking place during the evolution of the oceans. The comparative analysis that have been carried out and the relationship revealed indicate that, in the author's opinion, formation of continental platforms and oceans was associated with cyclic remodeling of the Earth expressed as merging of blocks to form mega and supercontinents and disintegration thereof, as well as formation of ocean. In Chinese opinion, those processes take place within so-called supercontinental diastrophic Wilson site every 800 million years. This site involves consolidation of continental blocks, their breakdown, formation of the ocean, and their development and closure, which produce a new collision of blocks which are now continental platforms. The Earth's transformation in the Wilson diastrophic site to have proceeded at intervals 1.85, 1.105, and 0.25 billion years. Evolution of the lithosphere and hydrosphere is tightly coupled with evolution of the bio and atmosphere, the coupling showing a number of relationships and feedbacks within the geosystem. The first diastrophic Wilson cycle, W1, involved emergence and consolidation of the Laurentia megacontinent. Those 1.85 billion years ago, the continental platform significantly expanded by the emerging Proterozoic crust surrounding the archaic craton nuclei, were consolidated to form the first megacontinent of Laurentia. North America with Greenland, Antarctica, Australia, and Siberia. The second Wilson site was 1.05 billion years, began after the Laurentian megacontinent created the cratonus of Baltica, Africa, South America, and India to form a first Rodinia supercontinent. That event was characterized by increased magmatic and metamorphic activities, expressed orogenic processes. Fusion of America with Gondwana, Alaska, and Greenland, about 200 million years, led to formation of the Pangea supercontinent, which corresponds to the beginning of the last Wilson site, W3, the breakup of Pangea in the Triassic, triggered process leading to Pacific remodeling, including the closure of the Tethys Sea, the emergence of the north part of the Atlantic, opening of Indian Ocean, and formation of South Atlantic. Major stages of transformation of the ocean. In the present author's opinion, Gramberg's model of the origin and evolution of the Earth's ocean make it possible to identify age-related evolutionary changes in both the ocean and in the continental platform mergings. Interlinking the process proceeding at each stage of evolution of the ocean facilitates exploration of process underpinning formation of mineral deposits, including oil, gas, and metals. The individual nature of each of the ocean is expressed geometrically and structurally by specificity of the geodynamic regime of their development. This is evidenced by different form of the type of divergent and convergent boundaries of the oceanic plate, continental markings, seismicity, volcanics, oceanic crust spreading rate, and within plate hydrothermal activity. Initial stages of the contemporary ocean coincides with geological periods corresponding to global events in reef generation. The Neoproterozoic in the Pacific, the Triassic in the Atlantic and Indian Ocean, and the Upper Cretaceous Paleogene in the Arctic Ocean. The global ocean rift megasystem can be divided into the following segments, differing in their spreading rates. Indo-Pacific, Indo-Atlantic, Indo-Mediterranean, and Arctic Gachel Ridge. You can see that global intra-oceanic rift megasystem is clearly divided in rich segments of spreading zones, converging at tri-junction nodes of the RRR type, Bouvet in South Atlantic, Rodriguez in the Indian Ocean, and Hess in the Eastern Pacific. Age of the ocean crust, differentiation of the oceanic crust plate mirror age differences of the oceanic fundament. The young oceanic plate includes the mid-ocean active ridges or rises from C1 magnetic anomaly to C4 and plate transform zone on slopes from C5 to C34. Parts of the plates which are characterized by normal polarity or non-spreading development, so-called a craterose quiet zone, a time interval between C34 anomaly and the Mesozoic 1M1R from 83.5 Santonian to 116 million years ago Aptian. The old oceanic plates had been forming since the formation of the oceanic ridge system in the mid-Jurassic from 161 to 116. You can see age of the oceanic crust, young oceanic crust and old oceanic crust, old here, and this quiet zone, and this young oceanic crust. There you can see you can see change of the sea level, relative average level of the ocean was 135 meters. There is 0. Okay, please, next. It's commonly held that Atlantic dates back to the early Jurassic and Indian Ocean dates back to the late Jurassic, in association with the beginning of spreading processes. However, the fracture of the continental crust, spread and submergence typical of rift stage of ocean formation took place in Triassic. Therefore, the geological age interval necessary for the formation of the contemporary Atlantic spans about 200 up to 250 million years, considering the Mesozoic age of the Atlantic, as well as its morphology, geological structure of the seafloor, composition and thickness of the sedimentary cover and ocean crust spreading tract. The Atlantic is regarded as staying at the major stage of evolution. Morphostructural analysis transfer fault system in the Atlantic demonstrate variation in their pattern and internal structure. Some of them show a simple structure expressed in the seafloor relief of a zinc branch, occasionally very long. For example, Fagulas and Romanche. The major role in formation of ferromanganese oxide deposits, polymetallic nodules, and cobalt-rich crust is played by the seafloor relief. Sources of components, structure and physical-chemical properties of water column, depths of geochemical barriers oxygen minimum zone, aragonite compensation depths, calcium compensation depths, and silicious compensation depths, near bottom dynamics and surface productivity. We can find in the world ocean three generations. The generations mirroring variability of condition and the time of formation and correspond to individual episodes of ocean evolution and transformation. The crusts are a direct manifestation of gradual subsidence of seamounts gyres. In their opinion, the existing data on the presence and distribution of cobalt-rich crusts and their metal concentration, including those cobalt, manganese, and nickel, are not represented enough to assess the character of crust deposits. Hence, they are not really able enough for the assessment of prospecting amenability of individual areas. It is difficult to regard data obtained from 9 Valvis Ridge or 12 for Rio Grande sampling sites as sufficient. It has been pointed out that the criteria recommended for prospectivity assessment, cobalt index, cobalt more than 0.5% and cobalt index more than 0.9%, crust abundance more than 50 kilograms per square meter, markedly limit the possibility of detecting highly prospective area in the Atlantic Ocean. I analyze all published data and taking into account number of sampling stations, cobalt index, cobalt, manganese, nickel, and thickness of this crust. It's a very, very thin crust in Atlantic Ocean. Next, please. Areas recommended for prospecting of the potential cobalt-rich manganese crust in Atlantic Ocean for prospection can be Madeira, Sierra Leone, Guyana, Brazil, Valvis Ridge, and Rio Grande. For existing data, the most promising area recommended for prospection is Valvis Ridge. Thus, considering the general pattern of formation of various crust generations, the object listed, Madeira, Sierra Leone, Valvis, can be regarded as the most amenable to prospecting. The prospecting value of the area, metal concentration, and nature of crust distribution can only be assessed from the optimal sampling site grid set up based on 1 to 500,000 map charts aided by images provided by side-scan sonar and photo profiling. Click, please. Click, please. 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 Click, please. Please click. Depths above 2005, area 111, cobalt index 091, and contents of cobalt very low. Next, please. Rio Grande, depths about 3,500 meters. Please, next. Valvis. Please. Okay, please. Please. Okay, please. Bathymetry and null area above 2,500 meters. Next, please. This area. Depths. Cobalt index 1.41 and cobalt more than 0.57. Area 139 square kilometers. This next. That's above 3,500, little bit larger. Okay. Distribution of hydrothermal cobalt-rich manganese grass in the Atlantic Ocean. This I show in this area. However, you can see that amount of sampling station is very, very low. Next, please. Hydrothermal massive sulfide ores in the Atlantic areas featuring the presence of massive polymetallic sulfides ores are associated with the Mid-Atlantic rich spreading axis, particularly so northern part, distinct by the occurrence of asymmetric rift valleys bordered by fracture slopes. The most promising area of massive sulfides or prospective are nodal basins which frequently form trip junction and intersection of transform faults at rifts. The highest concentration of hydrothermal wet sulfide deposits are found within the oceanic block situated between transoceanic fractures of Pico and 1520. Kurczato, Platystride, Oceanographer, Broken Spur, Tack Snake, Pitlogacze. This next. You can see map with the most promising areas. Kurczato, Platystride, Oceanographer, and concentration of metal. Next, please. Emergency and evolution of the Atlantic Ocean have been closely coped with stages of the Earth's ocean transformation. According to the age-based typology, the Atlantic is a mature form distinguished by a slow spreading rate and the presence of passive margins, blocks of the oceanic crust separated by transoceanic fractures formed in the northern part and southern of the ocean under differing geodynamic regimes. Ferromanganese oxide deposits and accumulation of hydrothermal Wern sulfides have formed in the Atlantic under the influence of environmental conditions that differ between northern and the southern part of the ocean, which is expressed different metal concentration. Knowledge on areas potentially amenable to prospecting for cobalt-rich crust and hydrothermal Wern sulfide ores is still insufficient and requires further detailed exploration and research. Thank you very much for your attention.
Obrigado, Dr. Richard, por sua excelente apresentação. Nós temos uma segunda apresentação antes do coffee break sobre um assunto que é desenvolvimento de recursos minerais, os esforços feitos pela Alemanha. Dr. Christian, por favor. Please.
Hello. Yeah. Good morning to all. Thank you very much, Mr. Chairman. Again, I'm going to present you some information about Germany's efforts and work.
Very important for you to choose the microphone very close.
Yes, it's better now?
Yes, because
okay. Yes, thank you very much.
Because like this.
Okay. Yeah. Good. Okay. Yeah, this is the title of my talk, and I will come only at the end of my talk to some references to the Equatorial and Southern Atlantic Ocean, because our main efforts concentrate on the Clarion-Clipperton Pacific nodule belt. And first of all, I want to mention that the majority of this work and of the results that have been accomplished was being done by Michael Wiedeke-Hombach and his team. And I think some of you will know him quite well. So next slide, please. This is a short outline of my talk. I'm going to tell you about our strategy. Oh, this is battery finished. Afterward, about the framework, with just some short remarks. Then about our history, what we have done in the past, and then, thank you. And then about the. It stops again. No problem. No problem. Then I'm going to tell you about our present activities, which one of a very important survey just was finished now under the conduction of. It's gone. It's gone. The battery is off left.
There is two buttons.
You have one.
There is two
Eve,
buttons.
thank you.
The blue button.
Okay, thank you. Thank you, Eve. About, and then in the, as conclusions about our future plans and the options we have. Next slide, please. Well, just a few words about our institution, the BGR, Bundesanstalt for Geosciences and Natural Resources. We are part of a tripartite assemblage of 3 institutions. Along with us are the State Authority for Mining, Energy and Geology. In fact, this is the institution which is doing the license work and administration work according to the German mining law. That is our license and our license contract with the International Seabed Authority is under the responsibility of this institution. And we are a federal institute and subordinated to the Federal Ministry of Economics and Technology, and this is the state of Niedersachsen, the economics ministry of Lower Saxony. This is the state where our institutions are located in. And last but not least, a pure scientific organization which is funded externally, the Institute for Geoscientific Joint Tasks. We are existing in this form, the BGR, since 1958. Next slide, please. And our mission is to give advice to our government, in particular to the Ministry of Economics and Technology, but also to the other resorts, and of course to the German industry as well. But as you know, by globalization, this is interconnected, in particular on a European basis, but also internationally. So we are cooperating with industry as well as with non-profit institutions and organizations in on the focus or on behalf of natural resources and geoscientific issues. So this is our expertise, also of course, like a geological survey of Germany, but we are a federal state, so the tasks are a little bit different. Yes, and moreover, we are strongly engaged in technical cooperation that is giving support to developing countries. This is within a strong cooperation with and funded by our Federal Ministry of Economic Cooperation and Development, and as well in a scientific manner with developing countries as well as with industrialized countries in the so-called International Scientific Technical Cooperation. That is a cooperation between the research ministries of the respective countries. And further on, we are doing strategic research in the geoscientific sector. Next slide, please. This is some figures about our budget and our capacity. Presently, we are about somewhat above 700 employees. That includes also the time-term employees, subdivided into about 40% of scientists and 60% of technical staff and administration, of course, 33 trainees, and our budget in 2007 was about 50 million euro. And last but not least, we applied successfully for another 30 million euro from third parties like the German Research Foundation or the Federal Ministry of Research or the European Community. Next slide, please. On the field, and I show this to you in that detail because the area we are talking about, that is the area in uppercase letters of the ISPA, is considered as the common heritage of mankind, and this means the inclusion in particular of developing countries. And this is what we have done on the sector of technical cooperation in the years of 2007 until 2008, and subdivided into the different themes like georisk, mineral resources, energy resources, groundwater, environmental geology, land use planning, advice in mining and environment, mining environment, and supra-regional activities like EXAT, ASQUA, and also Guarani aquifer, and if I'm not wrong, this is in Brazil. And as you can see from the map, we are concentrating on South America, Central America, Africa, Southeast Asia, and some parts of Middle Asia. Next slide, please. Our expertise in the marine sector comprises geophysics, for instance, and here you have an example. It's the red lines. It's a little bit faint here, but they denote our efforts since 1967, and our databases comprises almost 400,000 kilometers of two-dimensional multi-channel seismic data. This includes as well data here in the Arctic Ocean and around the Antarctic continent. Missing are the most recent ones offshore between Mozambique and Madagascar, and another set of data here in the Nares Strait between Canada and Greenland, and also in the South China Sea. Next slide, please. On the field of maritime marine geology, I just want to mention that we did a lot of marine geological and marine geochemical surveys, and some of the guests of this seminar will remember or have even cooperated with our geologists on some of these surveys, and you can see as well it's spread all over the world, but the geologists are more happy than we poor geophysicists. They are concentrating on the tropical areas while we have to go also to the very cold Arctic and Antarctic regions. Next slide, please. And also I have to mention our activities in the cooperation with the Integrated Ocean Drilling Program, formerly denoted as Ocean Drilling Program. And this is a map showing you BJAR's contributions in drilling proposals or own drilling proposals denoted in red color, and in yellow color where the ODP drillings have been performed along with the data of BGR and pre-site surveys. And I have also to mention that the German office, coordination office that coordinates all German activities within the IODP program is hosted by BGR. Next slide, please. Well, what induced BGR to engage in deep sea mining and in mineral resources of the deep sea? This is a figure presenting the rise in the market price levels based and calibrated to the beginning of 2003. This is indicated by 1. So the ordinate represents the factors that have to be used as for multiplication with the current with the previous price at the beginning of 2003, and you can see up to a factor of 8 for lead. That was at the end of 2007, and as we all know, this is in a decline right now, but nobody knows what will happen next, if it will accommodate at a lower level or if it will rise again. Anyhow, This was the major reason for BGR and for the German government to engage in this field and to provide future options for the German and European industries. Next slide, please. Well, just a few words on the next slide, please, on the framework under which we are working. Next slide, please. As you have heard by Michael Lodge, yesterday the law of the sea, the text body was adopted in 82 and it came into force in 94. That was just shortly after Germany has ceased to be active in the field of deep sea marine resources due to the decay of the price level of mineral resources. But here the situation has changed, and of course you all know the International Seabed Authority was established within the frame of the law of the sea, controlling activities in the area and defining regulations of its usage. Next slide, please. And what are the types of mineral resources of interest? The polymetallic or manganese nodules, the cobalt-rich crusts, and polymetallic sulfides. That was also presented in greater detail by Michael Lodge yesterday. Next slide, please. The regulations on prospecting and exploration for polymetallic nodules in the area, they were adopted by the Council in 2001, and 2 years later in Germany, the edict on regulations on the prospection and exploration of polymetallic nodules in the area came into force in December 2003. That's the Ausführungsgesetz execution law on the law of the sea of 1994. Next slide, please. Well, also mentioned yesterday the law of the sea, the relationship between law of the sea and the mineral exploration, and some of the focus points. You need a certificate of sponsoring state, the concept of reserved areas. I will come back to this somewhat later. The fees of joint venture with ISA, that is to involve ISA in the profits and for distribution to developing countries and landlocked countries under them. Know-how transfer between all the states parties and in particular to the developing countries. A training plan for trainees that were selected or have to be selected by ISPA, and of course, and last but not least, the environmental protection. The activities of BGR, they are all accepting and are all committed to these basic points. Next slide, please. Now I come to the history of our previous efforts. Next slide, please. In the 1970s and 1980s, the market price was also that way that private companies, in particular also in Germany, they initiated activities and developed concepts on mining of, in particular, polymetallic nodules or manganese nodules, and under them was the task group for mineral researchers, the AMR, and the Preussag company. Preussag has transformed, meanwhile, into a tourism agency, the TUI, and I think from time to time you can see some of their aircrafts here at the airport of Rio. And also non-profit institutions were engaged in these activities, like the BGR. This cumulated in 1985 when a newly formed consortium of AMR and OMI was applying for a mining license according to German law. The Seabed Authority was not established at that time, but this was not brought to an end because of the decay of the prices, and all the activities ceased. Now, 94 Convention of the Law of the Sea, on the Law of the Sea, and BGR, and the rise in the market price level induced BGR to take over all the material and all the huge comprehensive archives of this former consortium of AMR and OMI, and to relaunch its activities in this field. And finally, in 2005, BGR applied at the Seabed Authority for a contract on the polymetallic nodule exploration license, and the state of now was that in 2006 contract was signed between Ambassador Satya Nandan and representatives of our Ministry of Economics in Berlin. Next slide, please. Yeah, Dr. Vijay yesterday also explained the reasons why these polymetallic nodules are so interesting in economic terms. This is a 3% content of cobalt, copper, and nickel. Manganese is about 30 or 27%. Here in this distribution it is visualized. Iron 8%, and more than the half, about 62%, is not so valuable, belonging to the oxide hydroxide group. This is known to almost everybody, but what might be new is that these nodules contain also molybdenum, tellurium, selenium, and bismuth. And these are minerals that are looked for strongly by the computer industries. And so this might be another factor and another impact to enforce and to bring forward the research and production of these polymetallic nodules. Next slide, please. This is an early picture from an excursion or a survey in the manganese nodule belt by Sonne, German research vessel, Sonne Cruise SO25 in November '82. Next slide, please. Shows you the nodule coverage at the seafloor in a depth of, well, I think 4,000 meters or something like this. Next slide, please. And what data have been acquired and sampled, also concepts for production technology have been developed. This is a potato digger, or I have to say a nodule collector. But the concept is almost the same. This is remotely operated and operating in a depth of 4,000, 5,000 meters. And they have been technologically finished and also tested. But of course, the technology has made a huge progress since then, and so also this entire concept has to be reworked and overhauled. Next slide, please. Here you have the distribution of polymetallic nodules and polymetallic sulfides, but giving you the areas only of economic interest or economic concentration. The manganese nodule belt of the Pacific in a huge area south of India, and here along the mid-oceanic ridges, the accumulations of polymetallic nodules. Next slide, please. And here you can see in light blue the area under the legislation of administration of ISPA, and in darker blue the area of the exclusive economic zone, and you see that almost all of these occurrences lie within the area in the sense of the law of the sea. Next slide, please. The three types, manganese nodules, cobalt-rich crusts, and massive sulfides. The distribution thereof is here shown for the Pacific area, and I will concentrate here on the Clarion-Clipperton belt. Next slide, please. Well, here again you have the so-called Pacific nodule belt between Hawaii and Mexico along the equator, which runs about here at this position. Next slide, please. And some of the conditions are outlined here on this slide. We have heard it in several talks yesterday from Dr. Vijay and from Dr. Kontinsky. Also, carbonate compensation depth is a very important factor. Only below that so-called CCD, you have the formation of the polymetallic nodules. The upwelling zone at the equator plays an important role because it deforms the CCD, and also the sedimentation is an important factor. And Dr. Vijay is collecting all these data and properties, and also the proxy values that could form an impact on the formation. This is a 3D picture showing again this carbonate compensation depth, and the different here about is the equator, and showing the different regimes of sedimentation by calcareous and siliceous ooze, and the biggest nodules you have only in a very small sector. Then the diameter, the average diameter, is decreasing with distance from the equator. Next slide, please. Well, again, there is the concept of relinquishment, and to provide information and useful economic valuable areas for developing countries, and the rules are that you can apply for a maximum of 300,000 square kilometer. 50% immediately becomes license area, this part, and 50% is reserved area. And the relinquishment concept says that within the first 8 years you have to give back another 20%, then after 5 years 10%, and after 8 years 20% again. So the final license area is 75,000 kilometer and maximum. And in order to avoid this procedure of relinquishment, the strategy of BGR was just to apply for an area, total area of 150,000 square kilometers, so that immediately half of them have been given back, and the rest of our license area is 75,000 square kimeters. Next slide, please. Well, this is what has been left over, an eastern area of a size of about 60,000 square kilometer, and a western area of approximately 15,000 square kilometer, adding up to a total of 75,000. Next slide, please. And this is a situation map where these areas are located within the chorus of all the other license keepers like IOM, Comra, DOT. You have heard the names yesterday with the red circles. Our areas, the eastern area here and the western area here are indicated, and the white area below, and here at the east of that area, that's just 50%, and that's the belonging to the reserved area. Next slide, please. And here you see a previous assessment based on BGR's data, which we have inherited by Preußack and OMR, IOM in 2003. This assessment was reduced to the 75,000 square kilometer in a water depth between about 4,000 and 5,000 meters on average, giving an amount of ore between 800 and 900 million of tons. The average size of the nodules, or the diameter, were assessed to 5 centimeter according to the data and results available then, and concentration was set to 10 kilograms per square meter on average, and this resulting in an amount of cobalt, copper and nickel only of about 25 to 30 million tons, referred to the German license area of 75,000 square kilometers. But with the present survey and future following surveys, we will re-evaluate this assessment. This is a very rough estimation and based on the old data, and now we will revise it according to the new results. Next slide, please. Yeah, now I come to the present activities of BGR. Next slide, please. Well, we happened to charter the US-American vessel Kilo Moana of the Hawaii University, operated by the US Navy. This is a very modern ship. You see the construction is a catamaran, and not only a catamaran, but swath hull technology has been used. That means that the water area or the hull area that is in contact with the water at its surface is minimized. You see, compared to a monohull and a catamaran, these dark areas show the water contact area of the vessel, and this means that it is optimized in fuel consumption, velocity, and other characteristics. This vessel was chartered for a period from 13 of October to 22 of November. You see that the survey just ended last weekend, and Michael Wiedeke is on his way back home. And so we all are very eager to learn about his and his team's experiences with that type of vessel. As you can see here, you have a lot of space at the on the after deck. The breadth, I think, is about 20 meters. That is a huge space. Next slide, please. But what makes all research in this area, in the Pacific nodule belt, very, very expensive is that you have long mobilization and demobilization transits. So this is 1,200 miles to the western area and another 1,000 miles to the eastern area. These transits have been used to swath bathymetry and to collect magnetic data, not along the same ship track, but shifted by a certain offset, so that you have complementing coverage, so you get a broader strike. Next slide, please. The methods we have used, as I just mentioned, was magnetics, in order to better define the age of the oceanic crust. That is another proxy parameter giving you paleo conditions for the formation of the polymetallic nodules. This is a map and showing the spreading anomalies as they are interpreted as to now. And we are using a new concept that has been developed by BGR, that is a 3-component vector gradiometer that makes you independent of constant observation or constantly observing magnetometry observatories. Because, as we have seen on the previous slide, the research area is very, very far from each island or mainland. So you have the problem of the diurnal or daily variations. And this concept with a gradient system makes you independent of this. You only have finally to shift the level of your observations and to fit it to the regional level you get via connection ties. And basically also you can get from a two-dimensional survey, you get also three-dimensional indications by this method via the vector gravimeter, magnetometer here in the center. Next slide, please. Yeah, this is a contribution to finalize and to... Oh yeah, thank you very much. And to see how about the age of the oceanic crust. Next slide, please. The other method and the main methods used is box scoring, or sampling by box scorer, showing here on a slide. This is shown the system we were using. Next slide, please. A chain dredge, which has been developed with BGR. Next slide, please. Some samples showing you about the abundance which you can expect that the box scoring sample position 8, and this is, I think, 18 or 16, 18. In total, more than 45 locations have been sampled by this method. Next slide, please. And this is assessment of different areas, showing you the content and the abundance from few and small nodules in this sample to many and large, which is economically very valuable, over many and small, still economically valuable, as well as many and mixed. Next slide, please. And another important method is the bathymetry and side-scan sonar method, giving you information on the reflectivity of the seabed. And as you can see here, this means high reflectivity, the dark areas, and the high areas low reflectivity. This is a zonation that has been met, and from the samples taken in these different sample fields, we will try to make a correlation between the abundance of the manganese nodules along with the, or compared to the reflectivity, side-scan reflectivity. Next slide, please. In total, more than 60% of the eastern area and also 60% of the western area have been surveyed bathymetrically, and also, as I told you, more than 45 samples have been taken. Next slide, please. And now I come to the end. Future plans and options of BGR and Germany. Next slide, please. The current 5-year period, the research plan, comprised this cruise. I have told you the preliminary early results. Next year, 2009, they will follow the analysis and interpretation of the data and samples, and they will be integrated into the existing data sets, and the research cruise 2 is under planning, and we just have contracted a second time the Kilo Moana for a survey next year between. So the next cruise, in particular, concentrating on side-scan sonar, possibly deep-towed side-scan sonar, and more sampling will follow next year, in just about 1 year. And in the year 5, 2010, we will develop a nodule distribution model, at least it is intended for the German license area, and we will conceive the next 5 years research plan. Concomitantly, we are taking part in the training program of ISPA. That is, in the present cruise, we had 4 trainees that will be involved also in the after-cruise data evaluation at BGR in Hanover, and we have conceived a 4 months training program for 2 trainees in Germany. Next slide, please. Additional efforts. I just learned before coming here that our Federal Ministry of Economics and Technology has granted a demonstration project on marine mineral resources, which will be administered by BGR, but we do not the work. We will contract people. Well, again, about the sulfides we are offering, we have no idea so far about the distribution of manganese nodules in the Equatorial and Southern Atlantic Ocean, but we learned that there are options, and we are offering our experience and all of our capability for cooperation and to work along with the countries of this South Atlantic area, whoever it is. Could be non-profit organizations, but also industrial companies are welcome. Next slide, please. And again, regarding the energy resources, I just learned yesterday from the head of Petrobras that there is an extension of the Santos Basin and the prospectivity of the Santos Basin, possibly at least over the exclusive economic zone, but possibly extending also in the area. So we are offering our knowledge also in this regard. Next slide, please. Oh yeah, this is the exclusive economic zone. Next slide, please. We are experienced in data collection of more than 40,000 kilometers in the South Atlantic margins. Next slide. We have detailed theories about the opening history and basin formation history in the south between Uruguay and Argentina. Next slide, please. Sediment thickness information in the south. Next slide, please. And we developed a deep water, ultra deep water play, which could be tested. At least it shows that also in ultra deep water conditions, hydrocarbons could exist and possibly could be produced. Next slide, this is my end. Thank you very much for your attention.
I invite Mr. Dr. Richard and Dr. Christian to come here to answer the questions. Nós temos 15 minutos, aproximadamente, e a palavra está aberta. Dr. Roberto Ventura, Dr. Kaiser, Roberto Ventura.
You have it here.
Thank you.
Hello? Hello?
Okay. Can you hear me? Thank you very much for the presentation. I think you were very, very good. And I have some questions. The first question is for Christian. Anyway, my question is, BGR is a research institute, right? As far as I understood, the research institute. So now you have an area by ESA in the Pacific. So my question is, once you have everything set for exploration or exploitation, what will happen? Is BGR will exploit the area, will exploit the nodules? What I want to ask, what is BGR policy for that? The other question I have is about the sulfides in South Atlantic, and I noticed that the North Atlantic we have lots of sulfides currencies, and you plot the red areas there. And my question is whether we have or not some studies or detailed studies in the South Atlantic that's not really shown in that map. And finally, the other question I have is about environmental issues. I haven't seen, at least, didn't mention anything about environmental issues and concerning the manganese nodules. How, what are the baseline for environmental issues concerning some future exploitation of manganese nodules?
Yeah. Yes, thank you for this tripartite question. And I think it's very important to raise these questions. I come to your first part about production and exploitation by BGR. I forgot to mention, we are an authority. We are not only working in the field of science and research and development, but we are a federal authority, so we must not make competition to the industry in no way. We can cooperate with industry. We also can be commissioned by the industry if there is some scientific gain or advantage for our own studies, but we must not make competition to industry. So all exploitation and production matter is left to industrial and profit companies. I think this is the first part. Regarding sulfides in the South Atlantic or Equatorial Atlantic, we have no data so far. We work, as you could see from the two maps I have shown, on geophysical work and geological geochemical work. In geophysics, we have a lot of data collected in this area at the continental margins, only mostly within the exclusive economic zone or just next to it. But we have I don't think we have any survey marine geological or marine geochemical survey in that area. And also the archives of AMR Preußag do not contain any information for this area so far. But as I told you, we are open for cooperation. But this comprises our experience we gained so far. And the third part of your question was about the environmental issues. BGR has conducted, along with other partners in the 70s and 80s, a comprehensive program on deep sea environment protection. TUSH, it was Tiefsee-Umweltschutz, yeah. Deep sea environment protection. And also these questions are under special consideration, in particular by BGR, because we are cooperating also intensely with the Federal German Ministry of Environment, and so we are obliged to monitor and to make assessments like the comprehensive environment impact assessment for all of our works. There's a strong regulation in Germany, and also BGR by itself is interested to monitor the impacts on the environmental system. And as far as I know from the law of the sea, environment is a very high standard and point in this legal system. And there are also areas established for comparison of the impacts, untouched areas of equal composition and age and conditions, and the production areas. So there will be made analysis and comparison, and I think the ISA has the authority to stop any activity whenever this is dangerous and does harm to the environment.
Doctor? Microphone, please.
Thank you, both of you, for your excellent presentation. The first one will be addressed to Dr. Kotlinski. You have talked about the Atlantic Ocean. You have mentioned the lack of data, the lack of sampling station. Nevertheless, how can you make the assessment for the most promising potential, taking into account the manganese nodule, cobalt crust, and massive sulfides? In other words, what might be the feature of the Atlantic Ocean? Because today we all talking about the Pacific. Everything happening is in the Pacific. And the last question will be with Christian. You have said that you are willing, you are active in the Pacific, but you are willing to do some work in the Atlantic. What are you waiting for? Or who are you waiting? Thank you very much.
Thank you. It's my opinion, amount of the sampling station for the area square, more than 100,000 square kilometers, 9, 12, 6. It is enough. It is enough. And I think that we can speak about possible prospection in this area for the start, for the depths about 2,500. And then we have data to give correct opinion. Atlantic Ocean is not, it is concentration ferromanganese oxide, hydroxide concentration of basic metals, manganese, cobalt, nickel, copper, is really different as in Pacific Ocean. But I think that many areas can be perspective for in the future, of course. The same is for sulfides. but we have no too much data in oceanic reach of segments of the oceanic reach. But I think that, for example, Bouvet Tribune is perspective, in my opinion. However, we have no so many data for it.
Thank you.
Mr. Kasby?
No, it's okay, I think.
Oh, sorry.
Yeah, thank you for that question, and I can just follow to Dr. Kotinski, because there is lacking a huge lack of data in the Atlantic, and the Equatorial and South Atlantic, and this area is not on focus of BGR's geological and geochemical marine research so far. We are, as you can see, I have presented the figures of BGR and the budgets, but the marine division is only a very small one of this. Maybe in total geophysics and geology, the staff is maybe 60 people, including technicians, scientists, everything, geophysics, geology, geochemistry, all. That's not too much. We don't have own vessels. We always have to apply for funds. We have a very small budget to do our own surveys, but then we have to charter. This is a tedious administrative process. So all these people are occupied so far, and this means South Atlantic is not on present focus, but it can be. We are open if there is more information. BGR will not do the first step so far to acquire more data and to say maybe this is economically valuable, or we should compare this area and this area. This is a lot of time and money, and we will not invest this as the first protagonist. But if somebody says, we have an idea, we are doing this and this, and we have more information about this area, and we need some particular expertise, so BGR are interested to cooperate with us, so we are always open for this. Does this answer your question? Okay, thank you.
I would like to tell that not only metallic deposits in the South Atlantic, but we have taken into account high perspective oil and gas deposits, of course, of the very huge sedimentary basin and very interesting passive margin in this ocean. That is very important too.
May I add another comment again? Because you rose the issue of the energy resources. That is one issue we are working concentrated in the Atlantic Ocean, along with non-profit and profit organizations. But because this is mainly restricted to the exclusive economic zone, or possibly to the area of the extended continental shelf beyond 200 nautical miles. So this is not of interest for the aspects of the area. But so maybe there's a tiny opportunity which makes it relevant for that what we are discussing here. So this is just to see the relationship between our activities in the Atlantic and the Pacific. Thank you.
Thank you very much for your both brilliant presentations. I know that Mr. Kotlinski worked hard to prepare a map especially for this seminar on the South Atlantic. This map will be very useful. Yes, it changed a lot. Okay. We prepared also something like this, and I think we got the same results as you. And this is the starting point for the research we should do in the South and the Equatorial Atlantic, based on the few data we have available. Mr. Christian, sorry. Christian, you made a very good presentation about the VGR. We know that VGR is doing a lot of work. I have myself spent 2 years working with the marine geophysics team in the VGR, and I know that they are developing a lot of work all around the world, geophysics and geology. And it would be a very good idea to have a cooperation for the South Atlantic also. I have a question for both of you. We know that, for example, for polymetallic nodules, the metal content of nodules, the metal content of nickel and cobalt is higher in the Pacific Ocean. That's why most of companies are working there. And the nodules from the South Atlantic are richer in iron. From your experience, from your knowledge, could you say something about sulfides and crust? Is it possible to say now that sulfides and crust from one ocean is richer in metal of economic interest